Hello guys, how are you doing? I want us to proceed with linear inequalities which you had started. I'll be taking you through 4 more examples of solutions of linear inequalities and number lines. Let's get started. I want us to consider these examples. You are required to solve the following. Solve the following inequalities and represent the solution on a single number line and represent the solution on a single number line. And we are given 3 minus 2x is less than 5 and 4 minus 3x is greater than or equal to negative 8. You are required to solve these inequalities and represent the solution on a single number line. Like we mentioned in our last session, whenever you are given a question of this kind, this is what we refer to as simultaneous inequalities. And I remember advising you, solve the two inequalities separately, then combine the answer into one answer. So this is what we refer to as simultaneous inequalities. How do we go about it? Let's have the first one. 3 minus 2x is less than 5. Negative 2x is less than 5. Carry the 3 to the other side to become negative 3. So negative 2x would be less than 2. Divide this by negative 2. Divide this by negative 2. X would become greater than negative 1. Why is it becoming greater? We agreed in our previous lesson that whenever an inequality is divided by a negative, remember to change the inequality symbol so it becomes greater than. Which now takes us to the next thing. We have got 4 minus 3x is greater than or equal to negative 8. This will be negative 3x is greater than or equal to negative 8. The 4 will cross over to the other side. Being a positive, the 4 will become a negative if it crosses over. So this will then become negative 3x is greater than or equal to negative 12. Divided by negative 3, divided by negative 3. X will become less than or equal to positive 4. We have solved the two inequalities separately. It is strongly recommended that upon getting your answer, this answer should be combined into one answer. How will that be done? Do you take note? We agreed that when combining inequalities, the small number should always come first. In this case, the small number is negative 1. So we'll start with the negative 1. Because we want the x to be shared, that will force us to interchange the two. But we mentioned in our rules that when the elements of an inequality are interchanged, the inequality symbol should change as well. So this will become negative 1 is less than x. The reason as to why this symbol is changing is because the two elements have been changed. As for this other one, the way it is the way we will write it. So there's no need of changing this inequality symbol. So this becomes the solution to that simultaneous inequality. The question did not stop at this point. The question asked you to represent the solution in a single number line. will that be achieved? I will have my number line. We'll have negative 1, 0, 1, 2, 3, 4, 5. At negative 1, we will use unshaded dot. While for 4, we will use a dot that is shaded. Then join the 2 points in that manner. That is the range where the values of x lies. That brings us to another example. Let's consider this an example. You are now asked again to solve the inequality. Solve the inequality 2x minus 1 is less than or equal to 3x plus 4 less than 7 minus x. You are required to solve that inequality. Whenever you have an inequality involving more than one inequality symbol, this is what we call a compound inequality. The first thing that a student is required to do is to separate the two inequalities. How will the two inequalities be separated? I will have the first two. What do we have in the first two? We've got 2x minus 1 is less than or equal to 3x plus 4. Then I will again have the last two, and that will be 3x plus 4 is less than 7 minus x. Do notice that this part in the middle has actually been used twice, or it is finding itself repeating. It has been used for the first side and has also been used for this other side. So what do we have? We will then go through the normal procedure of solving inequalities. I'll carry the 3x to this other side. I'll have 2x minus 3x is less than or equal to 4. The negative 1 will cross to the other side to become a positive 1. What is 2x minus 3x? This should be negative x. It's less than or equal to 4 plus 1 should give us 5. We already know that whenever an inequality is divided by a negative, this symbol should change. So I will have x is greater than or equal to negative 5. Which now brings us to the second one. What do we have here? This will be 3x. Bring the x to this other side to become a positive x. It's less than 7 minus 4. 3x minus x, 3x plus x should give us 4x. It's less than 7 minus 4. 4x should be less than 3. Divide this by 4 and this one by 4. X should be less than 3 over 4. What then will we do? The two answers are supposed to be combined. How do you combine the two answers? These two will then switch. Reasons for doing that is because this x is supposed to be shared. Do remember, when combining inequalities, like I already mentioned, we only use 1x. If that 1x is going to be used, then that implies that the x will be shared. If the x must be shared, then the x should be brought in the middle. Like we already mentioned in our first rule of inequality, when the elements of an inequality are interchanged, the symbol should change as well. So this will become negative 5 is less than or equal to x. Then as for this other one, the way it is here is the same way I'm going to present it. So there's no need for changing the inequality symbol. And that becomes our solution. Which now takes us to the third example. What do we have in the third example? We have 3 minus 2x is less than x, less than or equal to 2x plus 5 all over 3. What is the question? We are required to solve the inequality and represent the solution on a number line. Solve the inequality and represent the solution on a number line. Like we have already mentioned, in order to solve this inequality, a student is required to start by separating. How do you separate? I will have this part, 3 minus 2x is less than x. Then I will have this other part, x is less than or equal to 2x plus 5 all over 3. Like we already mentioned, this part in the middle will always repeat, or let me say, it will always be used twice. You'll find yourself using it on both sides. So I will have negative 2x. Okay, let's transfer the 2x to the other side. So that we have 3 is less than x plus 2x. 3 would be less than 3x. Divide this by 3, this one by 3. 1 would be less than x. Which takes us to the other side of our inequality. In order to solve this, a student will be required to start by removing the 3. How will that be done? This will be multiplied by 3 and this other one by 3. 3 times x will give us 3x. It's less than or equal to this, and this will cancel out to give us 2x plus 5. The 2x will then cross to this other side, so that we have got 3x minus 2x is less than or equal to 5. This will be x is less than or equal to 5. Like we mentioned, whether the question mentions or not, the two answers should always be left as one answer. This time round, you notice that x is already in the right place. So a student is not required to interchange the two because the x is already in the right place where we want it. So this will just be written in the same way it is there. Then for this other one, I will also put less than or equal to 5. And this becomes our solution. How do we then represent this in a number line? In a number line, we will have 0, 1, 2, 3, 4, 5, 6. At 1, we'll use a dot that is not shaded. Then at 5, we'll use a shaded dot. Then have the 2 points joined like that. Which now brings us to the last example of the day. In the last example of the day, I want to consider a question which was brought in KCSE 2021 I mean. You are asked to solve the inequality. You are required to solve the inequality below and represent the solution on a single number line. What do we have? 5 all over 3 minus 2x is less than 1 minus 2 over 3 of x less than or equal to 2 minus x. How will this be solved? I will have the first two. Like we have said, you will separate this thing in this manner. I will have 5 over 3 minus 2x is less than 1 minus 2 over 3 of x. Then I will have this other one. 1 minus 2 over 3 of x is less than or equal to 2 minus x. What do we do next? We will then collect the like terms. What do we have? Negative 2x. Bring the 2 over 3x over to become positive 2 over 3 of x. It's less than 1. Carry the 5 over 3 to the other side to become 5 all over 3. If you engage your calculator, negative 2 plus 4 over 3, the calculator should give you negative 4 over 3 of x. If you engage your calculator, I suppose you get negative 4 all over 3 of x. It's less than 1 minus 5 over 3 should give us negative 2 all over 3. What then will we do? Why don't we multiply both sides by 3 to do away with the fractions? Let's multiply this side here by 3 and this side here by 3. The 3 and the 3 will cancel out, leaving us with the negative 4x is less than negative 2. Divide this by negative 4, divide this by negative 4. X would be greater than a half. Do remember that anytime an inequality is divided by a negative, the symbol must change. That brings us to this one. Negative 2 over 3 of x. We'll carry this x to this other side to become a positive x. It's less than or equal to 2 minus 1. The 1 will cross to the other side, the x will come to this other side. Negative 2 over 3 of x plus x should give us positive 1 all over 3 of x. And 2 minus 1 should give us 1. Like we did for the other one, let's multiply both sides by 3 to eliminate this fraction. These two will cancel out, giving us x is less than or equal to 3. These are the solutions. Now, the next thing is, whether it is mentioned or not, the answer must be represented as one inequality. How then will we do that? This x has to be shared. If the x must be shared, that will force me to swap the two numbers. In the process of doing that, remember that this symbol should change. Which is then less than or equal to 3. That becomes our solution. The question did not ask us to stop at that point. We are required to represent this in a number line. So I'll have something of this sort. At a half, half should averagely be somewhere here, in between 0 and 1. Then at 3, we'll shade our dot. This becomes the solution. That is how inequalities are done. Go do more practice. Have a nice time.